Okay, so this is page 2 of the synchronization notes. Section 2 is use cases, and that's for semaphores. And the first use case is as an event signal. The idea here is that one task signals another that an event occurred, then the other task can proceed. So in other words, the other task has been waiting for the signal before it went any further in its execution. We're going to use pseudocode for these. The reason I'm doing it this way, I will introduce the RTOS2 semaphores later, but it's a little more verbose and kind of hides the important concepts. So I hope that this simpler pseudocode will make it easier to grasp what's going on. So in this use case, the initial value of the semaphore is going to be 0 because we want the one task to block right away when it waits for when it waits on the semaphore. So step 2 is one task waits the semaphore. So that's bad grammar. We're taking a noun of a function name and turning it into a verb. And the step 3 is that I'll say one task, and this would be a different task, signals the semaphore, and this will communicate that the event has occurred. So let's just move this up a little bit. Here is our pseudocode example. We have, let's assume that our semaphore type is simply called semaphore. Semaphores are usually some kind of struct so that you can save some information about the count, but other things like which tasks are currently blocked on that semaphore and so on. I didn't mean to do a semicolon there. So semaphore S, and we need to initialize it. So let's just say semaphore S equals 0. Okay, so there's our initialization, and we'll have two tasks. Let's draw them side by side. So task 1 and task 2. So task 1 is going to do, let's use that infinite loop style that I showed you back when we did the scheduling, I believe it was. Loop forever, and the ... just indicates some kind of work that's being done by this task, and then it is going to wait on semaphore S, so wait S, and then it's going to block while S is 0, then it will do some more work, and that is the body of its loop. Task 2 likewise will loop forever. It will do some work, and it will detect or generate the event. So it may produce data, or it may read an input and realize that whatever event task 1 needs has happened. So then it will signal S. That will unblock the other task that's waiting on that semaphore, So then that task will be able to continue. So what this will do, these are concurrent tasks, so you're not guaranteed what order they happen in, but you do know that task 1 will not proceed past this line here until task 2 has reached this line here.